Alright, so we really stretch your brain today with 313 and the whole idea of a growing mindset and making connections between different things and how that kind of exercises your brain. The flipbook notes I'm going to give you are going to do that algebraically by looking at how transforming and manipulating some of the algebra can allow us to have two totally different transformations that look the same in the end. So yeah, we're looking at how two different transformations can give you the same final graph. So in the flipbook, section 313, we can kind of unpack this. So this will be at the bottom, and we're going to title this Stretching Exponential Functions. Recording here.
Recording?
Yeah, so anyways, we are going to look at one example where we manipulate the algebra to make it match. Kyle, I'm teaching right now. I'm talking to the iPad. That's Kyle in the background.
Alright, later. Juniors.
Hey Kyle.
Comment up on that or not?
Naviance. Find a so that y equals a times 4 to the x is equivalent to y equals 3 times 4 to the x plus 2. Alright, so if we look at this function, we have two different types of transformations going on. We have the 3 and the 2. The 3 is our vertical stretch by a factor of 3, and the 2 is a horizontal shift to the left 2. So the question becomes, how can we write a new equation that does not have a horizontal shift but has a stretch factor a that matches the graph below? And we're going to do that algebraically. So we'll go ahead and rewrite this function, y equals 3 times 4 to the x plus 2. And if you remember this rule of exponent, x of a plus b equals x of a times x of b, divide this up, we can apply that to this base of 4. So if we rewrite this, we'll have y equals 3 times 4 to the x times 4 squared. Use that property. Now you can look at 4 squared and 3. We can combine those like terms. So we have y equals 3 times 4 to the x times 16. 16 times 3 is 48. And sure enough, we match our original function with our shift and our stretch. Oops. Well, actually, we don't have the match, but it would be 48 would match this. So kind of the bizarre thing here is that an exponential function with a vertical stretch of 3 and a horizontal shift of 2 will give you the same thing as if you vertically stretch it by 48, and we just proved it with the math. Alright, so the second problem here is I gotta give credit to Shannon Gonzalez for helping me with the complex fractions and making all of our lives a lot easier. So complex fractions are not fun because a lot of you don't like fractions, and then on top of that you don't like seeing variables in the fractions. So we're only going to do one problem. We're going to look at this. A over b divided by 1 minus 1 over a. Now, what we're going to do is you're going to find your LCD, and your LCD is going to be whatever in your denominator. So a and b. So our LCD will be a times b. So what we're going to do is we're going to take the top and the bottom and multiply by ab. So we're going to distribute it to both. So if we see this, we end up getting the b's cancel up top, so we get a squared. And in the bottom we have ab minus the a's cancel here, b. Take this a little bit farther. and get a squared over a times b minus 1 for your final answer. Okay, so again, it starts with the LCD, which is here, finding that, and then multiplying the top and bottom by the same thing. The reason you can do that is a over b is the same thing as the number 1. Okay, hope that helps on this, and we'll get more practice with complex fractions. I'll be coming back in later chapters.